I'm really excited to be here in Berlin, joined by the Gnosis team and Scuttlebutt for the event that we have tonight. I think it's going to be a really fun one. I just wanted to come up here briefly to thank the family for allowing us to utilize this space. It's really exciting that we get to put this meetup on at a space that has become so important to the Berlin blockchain and startup ecosystem in general. I wanted to thank Ariana for the food this evening, also for the wine, local wine. And with that, I think we should dive right in because, we have an hour of presentations. I know it's a little warm in here. Everyone bear with it. But I wanted to take a moment to introduce Moritz, who leads the Dfinity, basically the Dfinity Berlin chapter. And dealing with global communities is such a challenge in of itself, but I would not be able to do it without the help of the community admins and organizers that we have all around the globe who have taken some real ownership of their cities and are really trying to collaborate with other projects and push just general knowledge all throughout their city. So Moritz is going to be basically introducing and being our announcer for this evening. So with that, Moritz, if you go up here, and we can get started.
Thank you. Thank you also for the kind introduction, Mike. I appreciate it. Our first talk today will be given by Cory Levinson. He's an active community member and also developer at Scuttlebutt, and he will give us a quick intro about what Scuttlebutt actually is. So, without further ado, please welcome Cory on stage. Thank you, everyone.
Hello, check. Okay. Cha-cha, cha-cha. So, the first question, do I stand here or do I stand there? Is this there? Yeah, now I've got this light, I'm looking at a bright, is this a sad light? Am I not gonna get depressed if I just let this shine on me? Okay. It's the summer, so that shouldn't really matter. Let's get started talking about Scuttlebutt. My name is Cory Levinson. You can find me on Twitter, KOHWI, or on Scuttlebutt @Corlock is my handle there. But searching by the handle won't really get you very far, generally for reasons that will soon become known. You actually need this hash, this public key, which is my actual identity on Scuttlebutt, because there isn't any globally unique namespace in the Scuttleverse. First thing we're going to talk about is kind of an overview of what Scuttlebutt is. Then I'm going to talk a little bit about the decentralized culture that exists there, and then kind of close things with some of the ways that things happen in the Scuttleverse. Something that I'm thinking about as kind of a soft governance that people have within the Scuttlebutt community. These little gift carton down here at the bottom, I just want to make a note that this is from a community member, Angelica, who made those. She's working on some great kind of visual imagery and GIFs within the Scuttlebutt community. So to start off, Scuttlebutt, let's kind of take a moment to just kind of start us with some etymology. It comes as kind of pirate slang for rumor or gossip. The Scuttlebutt had it that he was a government spy. So you can imagine people kind of gathering over on a ship around this jug of water where there's kind of discussing with each other the gossip, the things that are ongoing. Sailors would traditionally exchange gossip when they gather at the Scuttlebutt for a drink of water. And this image that you're seeing here in the background is a solar panel rig hooked up to a steering contraption on a sailboat from this guy, Dominic Tar. So Dominic Tar is the founder of Scuttlebutt. He was the one who started this project. He's a prolific kind of Node.js developer. And living on this sailboat here, he kind of had this need that he was trying to scratch where he wanted to communicate and be able to collaborate with friends and kind of have a social network that he could use in an offline setting, or in a setting where connection to the internet wasn't quite so easy, quite so available all the time. And so here's his friend, James Substack, who lives on a off-grid kind of solar farm in Hawaii. Substack and him will maybe want to chat, and through a mechanism like Facebook that may not be quite so easy, right? You're going to need to be connected to the internet, you're going to need to have a stable connection, and actually, if at any point in time your connection dies, your entire application goes down. You're not able to do any of the things that you would want to do. And so, you know, here we are, we're at a blockchain meetup, we kind of all think that we have the answers to all of this, and that the real solution is just, it's going to be Ethereum, it's going to be these things that were created, this great decentralized world where everything lives on this peer-to-peer network, but that still kind of depends on all of these computers being connected pretty much all of the time. Or a full node at least, you're going to want to have a pretty stable internet connection. So if we step back and we take kind of the approach that Dominic would take, we can think to ourselves, well, what are the actual needs that we're trying to satisfy when we're looking at a social network? And coming from that angle, we can also say, like, okay, well, what are blockchains actually really good at? And so one way that I think about blockchains being is that they're really a decentralized kind of singleton registry of people owning and controlling things. These owners and controllers can transfer those digital assets from one person to another, and so in kind of 2 points, blockchains can really be said that they're about identity, and they're about these identities kind of owning things or having some sort of asset transfer. Now, if we're looking at a social network, the requirements here are actually a little bit easier. The things that we need are identities, and the things that we need those identities to be doing are saying things. Now, those saying things don't really care about conflicts. There's not this situation of a double spend problem where when I transfer one coin from me to you, that other people need to be making sure that I'm not sending the same coin to 2 different people at 2 different points in time. So the idea of identity saying thing is something that really all you need is you just need a signature, right? You need someone to make a statement, claim, and to be able to prove that that was something that they said. And as long as that gets to you, then the requirements are kind of satisfied. So if we take this approach and we say that social networks are just people saying things, we can kind of bring this approach right to the computer and say that, well, if every computer kind of has a public key, an identity, and all of these statements that they make are just a chain kind of not transactions, but just messages that user is authoring, you kind of get the idea of what Scuttlebutt is trying to do. So you have public keys as identities, and you have these chains of signed posts that people are creating as messages. And so in a certain way, this is like a different kind of decentralization that we're talking about. So in Scuttlebutt, and this is a quote directly from an article that they have in their SSB documentation called Design Challenges, Avoiding Centralization in Singletons. And it says, SSB avoids peer-to-peer singletons partially to show that it can be done. Most peer-to-peer designs use distributed hash tables or global blockchains, and also because DHTs and global blockchains are just peer-to-peer versions of centralized systems. Social networks, on the other hand, are already constructed around a decentralized experience. So popular social networks have centralized implementations, like Facebook and Twitter, but you use them to interact with your peers. So on that level, the experience itself is kind of peer-to-peer. And so why couldn't we be building technologies that actually model that on the infrastructure level? So in a sense, here you kind of have a computer. Let's say this is Joe. Joe is kind of making all of these messages, saying all of these things about their life, and signing them with their ID, with a signature for their public key. And in the Scuttlebutt ecosystem, they kind of broadcast all of the people that they're following over a UDP port. And they might, let's say, over a local area network, bump into Sam. And if Joe and Sam are each kind of broadcasting that they're interested about the other person, they basically just swap their messages with each other. And all of these are stored locally. So now you have basically an offline first social network where Joe has all of the information from Sam and all of the posts that they made themselves. Sam has the same for Joe. And this could go on where in different cafes, people could kind of be bumping into each other, sharing messages with each other, and people can actually store messages from people that they don't follow. So the way that follows work on Scuttlebutt is in the UX and in the user experience, you're really going to see the people who you follow, but under the hood, your computer is actually storing messages 2 degrees out, 3 degrees out. And storing a couple degrees extra out allows you to transmit messages not just from the people that you follow, but from the people who follow the people that you follow, so that this way, when you're bumping into peers who might be interested in folks that you don't necessarily follow yourself, those messages are able to still move from one to another. And so when people hear about this, they're like, okay, that sounds cool, but the internet doesn't work by just like walking into cafes all day. Like that's not the main way that I want all of my information to get from me to my family who lives in another country. And so for that, you have these things in Scuttlebutt called pubs, which are basically these always-on users that are implemented as an SSB server that anyone can host. And so you post up a pub, you create it, and run it on DigitalOcean or whatever. And that basically acts as an always-on user that can follow other users, that can be followed back by other users, and can serve as an intermediary for you and your community. So within the pub ecosystem, you'll have new users following pubs. Those pubs will follow the new users back and thus expose those new users to the local community that that pub is connected to. And so all of this sounds like a lot of infrastructure stuff, right? This is really the technical ways that Scuttlebutt is working, and that's why when they talk about it, they're talking about Scuttlebutt as a protocol for kind of a cross-application social infrastructure where a lot of different things can exist on top. So you can have things like your typical social networks. There's different clients called Patchwork, Patchbay. MMMMM is a mobile client for Scuttlebutt. You can have chess. People have worked on implementations of chess that use Scuttlebutt as like the underlying infrastructure. There's also clients for long-form writing. I have a project that I'm working on around web annotations. And lastly, there's one where people are using Scuttlebutt as a kind of Git remote, so-called Git SSB, and building projects around code hosting and collaboration. And all of these under the hood are using the same kind of peer-to-peer architecture that we're talking about for Scuttlebutt. And so if that gives you kind of a little bit of an overview of how things are working there, I'm going to take a minute now to talk about the sort of culture that lives on Scuttlebutt as well. And now culture, I'm not just talking about the mycelium cultures that Glyph here is growing in his home, although that does happen a lot. You've got a little hashtag Myco channel where people are posting things like all of the different foraging that they're doing or growing of different types of mushrooms. But then you've also got people like Nico, who is making a little introductory post here about some open hardware and mesh projects that he's working on. He lives in, I believe, Brazil and is involved in the Libre Mesh project there. Trying to integrate that into the Scuttlebutt community and figure out ways that Scuttlebutt can play nice with a lot of mesh infrastructure. And then you also have people, so here's a prominent developer in Scuttlebutt, Andre Staltz, who is writing a post about the principles of Scuttlebutt. And one of the things that's like super exciting, I think, about this project is how you have a real community of people kind of all gathering together at the inception of this project, talking about the way that they want this community to grow, talking about the principles and the values that they want to instill. So some of the things that come up in that are talks of both independence and interdependence. What does it mean to have both of these happening at the same time, and how can we think about that? Principles of inclusion, pluralism, subjectivity, local first. As I said, it's like an offline first social network. And there's also a really great community of people who are active in different kinds of decentralized organizing. So Lumio, which is a project that's been around for quite some time, it's a platform for voting and small-scale decision-making for decentralized organizations. There's a lot of people and the founders from there who are active on Scuttlebutt. Also Inspiral has quite a large community on Scuttlebutt, and an example of that is this guy, Richard Bartlett, who's written a great book on patterns for decentralized organizing. So a lot of the people who are thinking in their daily lives, like, what does it mean to be collaborating in different kinds of ways? What does it mean to be organizing in different kinds of ways? Are here on this community, kind of living and breathing it and growing this culture with us together. And so with that, one of the things that people have started to do more recently is think about, okay, if we've got this project that we're doing, it was started by one guy and now it's kind of blossomed into this slowly kind of organically developing thing. What does it mean to organize around it? It on one hand is a development project, right? So you have the culture that already exists around GitHub, around people collaborating through issues and whatnot. But you also have a lot of people coming in here who are very excited about solar punk, who are very excited about off-grid living, who are wanting to get involved in different ways, but not necessarily technical people. So with that, you have folks who are experienced in project management and stuff like that, trying to help in more of a decentralized way, figure out what it means to grow and organize the processes here. So three kind of examples of that that I'll talk about quickly are one, this internal SSBC grants program, which I've been helping administer since about the beginning of this year. Another one is Mobile SSB Quests, which was a project initiated by Andre Staltz, who's the primary lead developer on the mobile application for Scuttlebutt. And then the last one is some discussions around maintenance funding. So with the SSB grants, this was initiated by a large donation in the fall of last year from Dfinity, so thanks to Dfinity for that. It was received by Dominic directly, but kind of at the inception of that, what he decided to do was throw up a GitHub project, kind of a couple markdown documents, and initiate a process where, okay, let's decide that we'll have maybe up to 4 grants awarding each month. Let's give around $5K for each grant. Let's have a very specific set of expectations for each grant, and let's rotate the administrative roles. So he kind of posted about this. People talked about it. All of the discussion was happening directly on Scuttlebutt for how this should happen. And then over the course of the next month or so, people kind of came to a consensus on how this thing would run. And since then, it's been going on. I believe the first one was in November, and we're now up in June, where we just had our last round of grants for this project, and it's been going quite well. There's been a lot of interesting projects, and I'll talk about a couple of them in a minute. But what's cool is that in addition to that, Andre also received a donation of around 50 ETH that he decided he wanted to use specifically for mobile development. So here you have different ways that money is coming into the ecosystem and different kinds of people taking initiative on how they want that money spent. And they're communicating it through the platform, they're talking about it with the community, and trying to have these collaborative discussions about how they want stuff to be done. So in Andre's case, he decided to come up with a list of the most highly impactful mobile tasks that he saw on his roadmap, and decided to give grants similarly of around 5K each for these larger chunks of mobile development that he wanted to see happen. And so now going back to some of the SSB grants work, just to highlight a couple of the projects that we've seen there. Some of the great things that have come out of this have been a lot of both developer and non-developer resources. So on the right, you'll see the Scuttlebutt protocol guide. This is kind of the first actual guide and specification that we've seen come out of the Scuttlebutt protocol. As it developed kind of organically, the project was pretty much documented through code. And so when someone took their own initiative to try and go in and really write up a documentation and give a lot of graphics to it, that was received really well by the community. And just on the left, what you see here is a kind of a more narrative storytelling approach that's meant to be a non-developer kind of introduction to Scuttlebutt called The Future Will Be Technical, by a guy called Zach, who's in the Scuttlebutt land. Up next, this is a project around artist residencies and emojis. So in the beginning, you saw the little grass garden emojis at the bottom of my first slide or so, and that was all by this woman, Angelica, who has taken it upon herself. So she's a comic, comes from a background in illustration, and is very active and excited about Scuttlebutt and the project, and decided that she wanted to kind of make Scuttlebutt a bit more of a visual culture and develop, on Facebook you have the 5 different replies that you can do. You can like, you can sad face, you can whatever. Well, on Scuttlebutt, we've got Hermes, who's our little hermit crab mascot, and with that, kind of a whole culture of different types of emojis for Hermes have started to develop, and she's led a lot of the work around this to try and make Scuttlebutt a bit more visually engaging and represent a lot of the values internal to the community. Luandro is a developer from Brazil who recently came up with a proposal specifically to make the ecosystem more inclusive for local communities around the globe, and trying to pave the road with easy ways to deploy mesh network kits and develop an ecosystem for SSB that's friendly for newcomers and especially for non-English speakers. So with him, he set out with a whole bunch of specific goals. One was to organize and translate SSB docs starting with Portuguese. Another was to develop a series of mesh kits for running Scuttlebutt on a Raspberry Pi. And then also he wanted to create a series of application hubs that would be able to serve as an entry point into the ecosystem for different types of Scuttlebutt apps to all be able to kind of have people get access to through one sort of direct hub. And then the last thing that he wanted to do was to sort of rigorously document this whole process and really kind of make a point of it being a social experiment in his hometown in Moinho, where he was trying to include more and more of the native Quilombo people in the process and incorporating feedback from them along the way. So before I kind of describe what this QR code is, I just want to say that the maintenance sprints that I talked about a little bit earlier, those are kind of this last class of ways that people are thinking about doing decision making and organizing work around Scuttlebutt. And the way that that's evolved is people just kind of getting into a thread. That's usually where it starts, with the Scuttlebutt thread, and discussing in a quite open way, like, okay, we think that we've got these few different ways that we're organizing work. What is missing? And maintenance has come up as a key kind of thing that people are wanting to tackle next. And so with that, there's a few different proposals that have come up. And hopefully, in the next coming weeks or so, there will be a bit more clarity around how the community wants to move forward with the funding of that kind of work. So this QR code right here is an invite link. It's not going to be a URL that you can go to on a browser, but if you do snatch it and grab the text, that can be used if you go to this website, scuttlebutt.nz, download the client Patchwork, and then if you paste the text from this QR code into Patchwork, that will basically connect you to a pretty reliable pub out there, hosted by one of the main devs called Mikey. And yeah, with that, thanks.
So thank you for this very interesting talk about a very interesting project, at least in my opinion. Are there any questions? Yes.
So if there's no global name registry, how do you call yourself Corlock on Scuttlebutt?
Check, check. No, really good question. So one of the principles that I mentioned that people have within Scuttlebutt is subjectivity, kind of embracing subjectivity. This is something I probably could have clarified a little bit. But essentially, you can self-identify as something, but anyone else can self-identify as that same name. And similarly, just as you can identify as something, you can also identify someone else as something too. So I call myself Corlock. Whenever anyone sees that, they will see a diary entry of me calling myself Corlock. And so in an ideal scenario, we'll have met through some other circumstance. We can exchange our public keys with each other. And then the Corlock is kind of a nice human readable way for you to see who I am. But there's nothing that prevents someone else from being a Corlock. And similarly, if I lose my computer, let's say, and I get a new machine, and I have no way to update this entry, on a new computer, I can actually identify from that other machine this to be dead Corlock or deprecated Corlock. And you see that happening a lot within the community where people will be identifying old accounts or identifying for clarification things that they for some reason or another can't do on an old device. That happen. Yeah.
Thank you. There was a slide where you showed Scuttlebutt principles. How does that work, like in a decentralized network?
Yeah, so I can actually go back to that slide because it starts with, I think, the post that Andre initiated the discussion with. So this kind of came out of the blue, right? It wasn't something that anyone had planned. It was something that someone decided they kind of wanted to start talking about, and he started with a post. He started with a post where he said, hey, so we're supposed to be principle driven. There already is a website. Someone at some point on the main website wrote some stuff on the principles page, but it hadn't been updated for a while. It wasn't quite clear the process for updating that. And so here Andre is kind of initiating a new discussion to say, well, do we want to refactor that? Do we want to rethink about what these are? And I'd say that Scuttlebutt is kind of blessed right now with a very kind of egalitarian, good kind of blessed community in the way that people are interacting with each other. And so the response to this was like, great. It was a lot of people chiming in with their own individual thoughts. It was a lot of people chiming in with tag-ons or additions to other people's comments. And then sort of in the end, you had one or two people kind of going off and maybe trying to synthesize. Or then you had another person, after that synthesizing was happening, try to draw up a little visual representation of these principles. And that's where things are now. I think Andre just yesterday or today, on the back of kind of this post, which was from about 2 months ago, made a nice little visual representation that kind of showed the principles in a way that made it look like a tech stack, like a tech diagram stack, where you had the high level, the low level, and I'm guessing that will probably make its way back onto the website at some point. But yeah, that was kind of the way that this got incepted.
Thank you.
So maybe one last question.
Great talk. Can I ask about how trust and privacy works on it? Can you follow anyone? Can you explain a bit about how that would work?
So similarly to how Scuttlebutt is kind of blessed with a really great egalitarian community, there aren't great mechanisms for preventing bad things from happening. I would say that there aren't as good mechanisms for preventing bad things from happening as people want. There's a few, but certainly there's a desire for there to be more. So you can follow anyone. It's an open network. You can also privately message people, which works by way of just encrypting messages for a specific person. So those messages will transmit over the open network. They'll get replicated just like all of the other messages, but they won't be visible to anyone except for who you're messaging. Other than that, it's a completely open platform, and as soon as public data is replicated on another machine, it's visible if it's public to anyone who would be able to see it. Now, in terms of bad actors, what you can do is, in addition to following people, you can actively block people. And what's nice about blocking is similar to following. When you're blocking someone, you're not just saying, I don't want to see anything from this person. You're kind of doing one additional thing, which is preventing your computer from replicating that person's data. So in a way, blocking also serves as this way to kind of fragment and partition communities. So what you'll see is if there's some people who are behaving poorly or that one community doesn't really like, you'll see a bunch of folks and maybe their friends decide to block someone, and then that person's messages won't be visible to that community as much anymore.
Does it help with data mining and stuff? So can a company just come on and data mine everyone's data because they can follow everyone on the network?
So you could follow everyone on the network, but what you wouldn't be able to do is, let's say, follow or get invites for all of the pubs on the network. Like theoretically, we're here in the family. I could decide to start up a Scuttlebutt pub here and give a handful of people invite codes to it. And if those handful of people aren't connecting to any of these public pubs, there's no way for data mining to get access to this, right? The data never actually leaves this area unless one of us goes and connects to a public pub. So certainly there could be a situation in which scrapers are coming up and kind of mining for data, but I think that when that happens, when there's enough data for that to be feasible, hopefully the number of pubs out there will be a lot more partitioned by communities, and so there won't be quite as easy a way for someone to go to just one spot and get the whole network. Thanks.
All right, thanks again, Cory.
Okay, as promised, this talk will be about decentralized exchanges, but very shortly, kind of before we dig into decentralized exchanges, why are we, Gnosis, doing or building decentralized exchanges? And that's, I will start with what kind of our main product or main thing is, that is prediction markets. So prediction markets are a simple tool to predict the outcome of future events by making them tradable. So it's quite simple. If you want to predict when Dfinity will go live or something like that, you could create a prediction market. And we have here an example, for example, on Cosmos. Will the Cosmos be live on the mainnet, or kind of will the mainnet run by August 1st? And what we do is we create just two simple tokens, and one represents the outcome yes in this event, and it will pay out one collateral token, so one Ether, if this event happens, and we have the outcome token no, that will pay out one if it does not happen. So what I could do here, I believe yes, they will be live. I know them. They sit across from us in the full node office, so I know sure they will do it. So I can put in here 0.1 Ether and would buy 0.23 of those outcome tokens, those yes outcome tokens. And yeah, by that I would move the price or the prediction up. and by that the market would get a better idea of how likely that is to happen. So those are prediction markets, and from now on I will only talk about decentralized exchanges, but I wanted to give this this intro because it should make clear why we are interested in decentralized exchanges. And as soon as I find the play button, then I will also look to you. View, go tools. What's a shortcut for it? View. Oh, here we go. All right. Okay, great. So, so what I just did is I spent 0.1 Ether tokens to buy some of those yes outcome tokens. So on a very technical level, all I did is I exchanged one token for another token, and that's all decentralized exchanges are about. So on a very basic level, a prediction market is just also trading tokens, and the only thing that's different is that those are special tokens. So that's kind of our need, why we, as Gnosis, as someone who wants to build decentralized prediction markets, need decentralized exchanges. And I will present now two approaches of decentralized exchanges, and the first one will be what we call the Dutch exchange, and that is something we have fully implemented, and it's running on testnet, and it's very, very close to be released on mainnet. And you might wonder, okay, there are plenty of decentralized exchanges being built right now, why we are building another one? And the reason is that we differentiate, or we would differentiate between non-custodial decentralized exchanges and fully decentralized exchanges. And the difference is that most decentralized exchanges are just non-custodial decentralized exchanges. So so the exchange is not in custody of funds, but the matchmaking mechanism, that is still done by a central entity. And that central entity then still plays a critical role. This central entity can do all kinds of things. It can do front running, or it can manipulate prices. It, first and foremost, it can control which tokens are actually traded. And what our goal was to build a fully decentralized exchange where also the matchmaking is done in a decentralized way. And that would allow basically an open platform where anyone can just list their token. And we also went further and wanted to have the infrastructure around it, like the website where you can interact with it. Also, that should be decentralized. So we are using IPFS and ENS. We will talk about that later. But first of all, what is the problem? Why are currently projects going this semi-decentralized route, where kind of they are non-custodial, but they still have a centralized matching engine? And it turns out the reason is because it's hard, or there are some problems if you just take the usual order book approach and put them onto a blockchain. So usually kind of on an exchange that you might all be used to, like Kraken, they have an order book, and it's called continuous double auction. And you have limit orders that defines a spread, kind of the difference between the best bid price and the best ask price. One important characteristic is that you have a serial processing of orders, and for that you need kind of an exact order of the orders, and that is something you usually do not have on the blockchain, you have it within one block. You have an order of transactions, but that is fully at the control of the miner. So the miner can order the transactions within a block as they like. So in reality, you don't really have that fine grain order of orders, and you shouldn't order that is in the same block should still be treated as another order in the same block. So that is one of the problems is the so-called front running. So as soon as you submit an order, let's say you're buying a lot of one token, so everyone knows the price will go up. Then this order is already published, and everyone can see it because it's broadcast. It's broadcast to the miners, and the miner could react on this information. So the miner could use this information and just buy already before your order hits the exchange. Could already buy this token and kind of game you. So you when your order will be processed, the asset you are trying to buy is already more expensive than it should be, or at the moment when you submitted this information. So what we are, what our solution to that is are batch auctions. So in a batch auction, all orders that are in the same batch are treated equally. And there are two ways, or there are many ways, but there are two ways that we have chosen to implement how you can build a batch auction and how you can come to this solution where, again, within one batch, everything is treated equally. And the first one is called Dutch auction. And the second one is the batch auction that we will discuss later. But first, how does the Dutch auction work? The Dutch auction works that you have a group of people that want to sell one token, and they all put their token together. And at some point, the auction starts, and it starts at a high price. So it starts in our implementation. It starts 2 times the previous price, and over time. The price will continuously go down, and at any time, people that then who want to buy can submit their bids. So basically, if you're happy with this price, at this point you can submit your bid, and continuously people will submit their bids until there are enough bids to buy kind of the whole batch, to buy everything that was bundled in this batch, and at that point. The auction closes and everyone will get the same price. So even if you submit your bid here at the higher price, so you're willing to pay even more, you will still get the better price. And that eliminates this problem of front running. So even if you, if you submit here and kind of someone reacts on this information in the end, everyone will get the same price. So those are just it's just basically just what I said again. We will start. This will go live on Ethereum in the next weeks, and we will start quite slow or quite conservative with the parameters. So in our implementation, such one of those auctions will take on average 6 hours. It means after 6 hours, the previous price is reached, and on average that should be then the closing price. If the price drops, it will take a little bit longer. After 24 hours, it will actually reach the price 0. So it's kind of guaranteed that after 24 hours, it's over. Once auction 1 starts, automatically, if that ends, the next one will be triggered. To start, it just needs a specific threshold to reach kind of a new cell volume, and as soon as that threshold is reached, it will trigger. The next auction. So again, the advantages are bundling of liquidity, no front running. You can find a price on even not so liquid assets, and the big advantage, it's all fully decentralized, so you're not reliant on a single operator. So if you want to build, that is specifically interesting, if you want to build stuff around this mechanism. So let's say you want to create a lending contract where you do collateralized token lending, and you need kind of a reliable price feed, and you need a way to liquidate an under collateralized position. If you want to build those infrastructure, you don't want to rely on a centrally operated system. You want to rely on a fully decentralized system. Just another example. So markets are quite volatile, so often there is no good reason why someone should get in a very short time frame very different prices. With the Dutch exchange mechanism, basically everyone would get, or within 6-hour intervals, everyone would get the same price. Of course, it comes at the cost of slower trading, so this is only useful if you can afford that, but for many use cases, like you just want to invest longer term in something, it doesn't really matter. That it takes that time. If you are willing to hold it for many months, the token you're buying, you might just be fine with a trade execution of 6 hours. We did kind of some optimizations around gas costs, but I don't want to go into details here. Yeah, the problem with other ones is that sometimes people try to fill the same order, and then the one, if you're coming late and you're trying to fill the same order that someone else is filling, then your transaction is cancelled and you still have to pay gas costs. It's one of the problems of other mechanisms. Yeah, one more thing I haven't mentioned, this Dutch exchange is also usable by other smart contracts, while other mechanisms that require off-chain signing are not. This is just how it looks like. In the end, it looks like Shapeshift. You just select, or at least as for a seller, that is a simple interface we have implemented. You just select the tokens, specify how much you want to sell, and click submit. No big surprises here, and then the auction will start. And once it's over, you can claim, whatever the outcome was. A few notices on the hosting. So that was all kind of more or less on smart contract level. To be fully decentralized, the hosting should also be done decentralized. We are finally there with Ethereum to have ENS and IPFS hosting enabled. So MetaMask, the pull request is already public, and they are merging it soon. MetaMask will enable ENS resolving, so we will have for the Dutch exchange, we will have a ENS entry that points to the specific IPFS content hash, and the content hash will contain the website. And to complete that, all of that will be controlled by a DAO. So there will be a DAO, and we are using DAO Stack. That's one of the DAO frameworks that's currently being built to control some parameters of the decentralized exchange, and also those ENS and IPFS entries. We are trying to give this DAO some control, but limited control. So it might change. It might even upgrade the contract. It might change the IPFS kind of the website, but it can only always do it with a let's say 30-day delay. So every user would have enough time to withdraw if the DAO would ever publish malicious code in a way. The DAO itself will be governed by those who are using the decentralized exchange. So kind of there will be a setup period where for 3 months everyone can trade, but there is no DAO in place, and you can kind of earn your voting rights, and there will be no pre-allocation of voting rights, so the voting rights will purely be earned by using this auction mechanism. Okay, that was the Dutch exchange. I want to briefly give you also a preview of another batch auction mechanism we are working on in parallel or working next. So it's a more complicated system, but also much more powerful system. We call it the D exchange, and it also uses batch auctions. But the new one will use something we call multi-token batch auctions with uniform clearing prices. I will show you in a second what that means, and it enables what we call ring trades. So if you go the step that you implement those batch auctions, you can achieve interesting things. And one is that you can suddenly match traders that you couldn't match before in separate order books. So how it works on GDEX, you have a token pair, or well, you have a exchange pair, let's say Ether dollar, and you have an exchange pair dollar Bitcoin, and you have an exchange pair Ether Bitcoin. And if you have one user that wants to sell A for B, and you have one, and so on this pair you have one user selling A for B, but you have no user selling B for A, you can't find a match. But you might have a user that sells B for C, and again you have no user selling C for B, so you can't find a match. And here's the same story. But if you look actually at those three trades, trades at the same time, and with a batch that is possible, you can actually see, well, there would be a match, or you could kind of execute those three trades all at once. And that is how we design the D exchange. So we have a list of, let's say, n tokens or 20 tokens, and it's possible to express order from every token to every other token. So that is specifically interesting if you assume that in the future there will not be one dominant currency. So on the New York Stock Exchange, it's kind of simple. There are, let's say, 100 tokens, so stocks. And they're all traded against the US dollar. So then it's pretty straightforward. You have 100 order books, and that's fine. But I assume, or we assume, that in Ethereum or in general in this blockchain world, we will go away from this concept of having one dominant currency like the US dollar. And even if it's just different stablecoins. So by the end of the year, there will be at least 10 stablecoins on Ethereum. So we have 10 tokens that all try to be worth one US dollar, but they are still different tokens. So if you would want to do the traditional order book approach, you would have actually 10 different order books of US dollar versus US dollar 1 versus Gnosis token, and US dollar 2 versus Gnosis token, and kind of the liquidity would be totally separate. With that approach, you can have all those stable coins in one system, and then a bunch of tokens, and then you can have just people just doing the trades between the different stable coins, and you can then in a way bundle all the liquidity of all stable coins versus one other token and execute that in one well, kind of atomic transactions. So yeah, the goal is to build a freely accessible, highly efficient, blah blah blah, global market, global exchange, and there should be no arbitrage possibilities. So kind of each price finding round should create arbitrage free sets of prices. So you can formalize that, and what you actually end up is an optimization problem. So you have all those orders in this batch, and at some point the batch closes, and you need to decide, okay, for each token, you need to define, or you need to find prices. And depending on what prices you set, at what price you set each token, you can enable different trades. So that is the optimization problem. And what you want to optimize for is something, defined as trader welfare or trading volume. So you would just try to maximize trading volume. So finding that those prices that enable most of the trades. So in the end, you can, well, that's how it could look like. You have all those tokens, and after one round of execution, you kind of enable all those trades. And in the end, you might have those ring trades. In the end, of course, everything needs to add up. So on one pair, you might have an imbalance, but then this imbalance can be closed via another pair. So very roughly, I won't go into details here. You can talk to us directly. A bunch of Gnosis teams are here. So we are implementing that as a plasma chain. So there's the main Ethereum root chain, and roughly the process or the steps are first, and that's something I haven't mentioned so far, is you for each batch you create a key, and you use, or we are using something called distributed key generation. So we are generating a public key, and all orders then can be encrypted with that key. And then you have that period, this order collection period, where you collect all the encrypted orders. The good thing is they are encrypted, so the operator of this plasma chain has no chance to discriminate or censor specific orders, because again, they are all encrypted. You need something double signing, that's a detail, but in the end, then kind of the chain locks down to that badge. The key service, this distributed key service, then publishes the private key. All orders can be revealed, and then you have this game where you try to, or you open up this game where you try to find the best prices. So you're starting a game for this optimization problem to find the best prices that enable the most liquidity. You might use something like TrueBit to verify that the solution is actually valid, and then you can finally settle the prices. I will leave it here, and we'll just have a few last remarks. So that was for now about decentralized exchanges. If you want to learn more about that, first again, we are here, but also we will host a conference about that and other things here in Berlin. Just wanted to invite you there. Roughly in 1 month, 19th and 20th of July. We have a bunch of interesting speakers. Just wanted to invite you there. And yeah, that's it. Thanks for your attention.
Hello, hi, my name is Rufo Guerreschi from the Trustless Computing Association. The goals are extremely desirable now to mitigate the risk of gaming and hacking of exchanges. Now everybody knows this is a big problem. And it seems now the techniques you're deploying definitely can now mitigate substantially these risks, this offering. But what about the medium and long term? So what, as a user moving to this platform, what kind of guarantees do I have on the medium and long term that the governance behind it will prevent the new software to be hackable or gameable? And this could be by accident because you're not good enough developer, or because you're maliciously trying to get rich around it. So what kind of standard certification bodies now maybe externally from the company maybe you're planning to deploy, and what also guarantees you have that people can just buy you out once you have all the market because you're more trustworthy? Some malicious player just buys you out, you cash out, and everybody's screwed.
Yeah, ideally we are not in the position to be able to do that. So ideally at some point, even if we would go malicious, we couldn't, because then it's fully decentralized. Of course, there is the big question about smart contract security and security in general, whether those mechanisms that you think of actually work the way you think of them. I don't have kind of the perfect answer here. I just can say, well, we are trying to go through a very rigorous process of publishing kind of the concept, publishing the specifications, publishing the security assumptions, doing then smart contract audits and all that stuff. But at the end, the goal would be that in the end you don't have to trust us in any form. And even if we would go totally malicious, we couldn't do anything about it.
One more question. You talk about Dutch auctions or other type of auctions, and there, because of low liquidity of prediction market. And otherwise, Gnosis talks about power of crowd, or the wisdom of the crowd. How does it fit to each other? If there's no liquid market, there's no crowd there.
Well, yeah. Well, I mean, I would say that there are enough markets, or with prediction markets, you can create very specialized markets, and it's true. For those very specialized markets, you won't have a huge crowd, so you will maybe just have 10, 20 experts participating in those markets. And then you need robust mechanisms, market mechanisms that still find a reliable price. Other markets, well, there you might have a true crowd, and their kind of traditional market mechanisms might be fine. So in the end, well, we are building a platform and trying to offer as many tools as possible that might suit different types of questions or markets.
Okay, so you mean crowd could be few people?
I mean, crowd. The interesting thing about prediction market is not necessarily that so many people will participate in the market, but the interesting thing is that so many people have the ability to participate. So the interesting thing is, if you ask specifically 10 experts, well, then you are limited to those 10 experts. But the goal would be that, well, millions, if not billions, people can participate, and that is that the true experts, and you don't know who they are. So kind of if you have to upfront enable them to participate, then that's a problem. Then you lose them. But if they can just participate, they actually know that they are the experts, and that is the power of the prediction market, that you enable people to participate. And it's fine if in the end not too many participate, but a lot of people should be enabled to do so.
Okay, thanks.
Hi, thank you for the talk. I was just curious about, in a situation where you have, say, low liquidity in a prediction market or in this decentralized exchange, the Dutch auction seems to be a great solution, especially for front running. One of the problems is the timing of it. It takes 6 hours to 24 hours. Were bonded curve contracts ever considered, and was it just front running, if so, that prevented them from being a solution?
Yes, we actually use them right now. So in the version that I showed in the very beginning, we use we called them, before bonded curve contracts were a thing. we already used those things, and back then we called them just automated market makers. LMSR is one implementation, logarithmic market scoring rule, and yeah, that is very useful to find this liquidity. Or to ensure that there is enough liquidity. Front running definitely is an issue, but still, we would say they are useful, and they are kind of just one tool in the toolkit. One downside is, of course, you need to find someone who, or at least for how we implemented them, you need someone who's upfront, kind of subsidizing that, or is subsidizing that market maker. There might be ways to do that without, but I'm not sure about that.
So maybe last question. You wanted to ask a question, right?
Hey, thanks for the talk. Have you considered implementing the basic derivatives, basically like shorting or binary options?
Sure. Well, of course, yeah.
So it's in the roadmap, or?
Well, I mean, it's something we want to make as easy as possible to enable other people to implement that. But of course, prediction markets, binary options are trivial to implement them. With the Dutch exchange, you get a reliable price feed, a decentralized price feed. So yeah, that is one of the things we want to enable with the tools we built.
But you enable it, or you are considering of implementing it as well? Into your
right now it's not high on our implementation list.
Okay, thank you.
All right, thank you, Martin. So before we head on to the next talk, maybe we... First, before we begin, I want to explain why I'm here today. Because actually, like 6 months ago, at Christmas time, I first heard about Dfinity. A friend told me about it, and I checked out the website, and I was really excited about what they were planning to do. And I asked myself the question, how are they going to do it? So I joined the Rocket Chat, and this is where I met Mike back in January, I think. And yeah, this leads up to me here now today, and I'm really glad and happy to be here. So please welcome Dominic Williams. He's our CEO and chief scientist, and he will give a brief overview about what Dfinity is and what we're actually trying to achieve. So please welcome Dominic Williams. Thank you, everyone.
Hi. So my plan is to give you a very brief overview of Dfinity, and then move into a Q&A session. And if necessary, dive into some more slides and go as deep as you like in whatever subject you like. So Dfinity is a project that in some ways is similar to Ethereum, but has a lot of significant differences. It's been a long time in the making. It kind of, this thing's funny. It can be traced back to a 2014 project called Pebble, which was researching ways to make faster cryptocurrencies, among other things. And the Dfinity project really born at the beginning of 2015, and was created from the outset to create a blockchain that would be enormously scalable and could potentially host internet services. The idea being that you could have a decentralized Twitter, decentralized Facebook, even a decentralized search engine. And it pursued new ideas about how you can create random numbers in a decentralized network, and then use those random numbers to drive other network protocols. And you may have, has anyone ever heard of the word threshold relay? Threshold relay? Yeah, cool, a few of you. So, at the heart of it is this thing called threshold relay, which is the first truly unstoppable, unmanipulable, and unpredictable random beacon, which generates random numbers incredibly efficiently in a network of arbitrary size. The beautiful thing is you get this sequence of random numbers that everybody agrees on. There's absolutely no chance of disagreement or a split in the network or anything like that. And you get the sequence of random numbers without running a consensus protocol. And it turns out you can use the sequence of random numbers to drive other protocols. And that's the engine of Dfinity. So we always thought, okay, we can create a blockchain computer, which is a bit different to a straight blockchain, something more like Ethereum, that would scale to enormous capacities, and that we could also make run very fast. Anyway, here we go. So going back to basics, what is the internet computer? So this explains the progression, if you like. You can start off by describing a computer mathematically. That's what von Neumann did and Alan Turing did, right? A computer is really a virtual thing. It's a description for how you process data and instructions. So once you've defined what a computer is, you can then create a physical implementation. And here's a computer created by a physical machine, right? That's what most of us think of when we hear the word computer. We think of something like our laptop or a smartphone. And the interesting thing is that you can also create a computer from a network of computers. And that's what the internet computer is. So it's just creating a single network, a single computer from a network of computers. Of course, miners are involved. It's very different to something like Bitcoin or Ethereum, where everyone's doing these proof-of-work puzzles and just burning electricity. But miners run symmetric nodes are all the same. We create specs. Imagine a sort of mid to high-end server machine. That's what a node kind of looks like, right? And miners run these nodes to earn Dfinities. And these nodes connect together over the internet, running Dfinity protocols in order to create the internet computer. And of course, it's fully decentralized. There's no central controlling party or anything like that. There's no DPoS, the EOS 21 servers in a ring, nothing like that. It's a fully decentralized network. And we keep a test net running with about 500 computers in it, distributed around the world. And it's very, very fault tolerant. You can knock out a big chunk of those computers, and the thing keeps on running. A big chunk of the computers could be controlled by a malicious miner. It would continue running. Does that make sense? So this is the crucial piece that, among many that we're addressing. If you want to grow the capacity of this big shared computer, join more nodes to the network, right? So if you increase the capacity of the shared computer, you can install more software, you could run more computations, and you can store more data. And the aim is, of course, to scale this thing up so we can host millions of systems. Next question, what will run on the internet computer? So the internet computer is going to run us software that adheres to a standard called WebAssembly. Who's heard of WebAssembly? Great. So WebAssembly is the first open standard for universal software that runs anywhere. And actually, it's already been implemented inside of all of the main web browsers. So this isn't a pipe dream, it's actually happening. It's a little bit like an open version of Java. Java if it wasn't owned by Sun Microsystems and then Oracle. But of course, it's had the benefit of almost 25 years of experience. It's designed to run on a much wider variety of platforms, and it's just better designed all around. And it's uniquely suited to this kind of blockchain application. So, if you like, those web browsers are the front-end support, and Dfinity is the back-end support. You can write your back-end software in WebAssembly. Actually, one of the co-creators of WebAssembly, he also leads the WebAssembly standards process, is a Dfinity staff engineer. So it's good. We have a good seat at the table where we can make a lot of it, push things into the standard that are useful. So we recommended a new opcode that speeded up our cryptography recently that was accepted and so on. Where did Dfinity come from? So this is one way of looking at it. Back in 2009, Bitcoin launched, and it was the world's first stateful decentralized network. So a stateful decentralized network is different to a standard decentralized network like BitTorrent. So in BitTorrent, the participants in the network don't have a common view of anything, right? You can search the BitTorrent network for a file, but people don't share a common view. The innovation in Bitcoin was that you could have a decentralized network where everybody could have a common view of some shared state, in this case a ledger. It's a very simple thing. It's like a 3-column ledger. So in the first column you have addresses where coins can reside. In the second column you have a balance of Bitcoin residing at each address. And in the third column you have an access control script. And if you can unlock the access control script, you can move the Bitcoin at an address to a new address. That's pretty much it. But it was a huge innovation because never before had it been possible to create a decentralized network where everybody shared the same view of some state. So although a ledger is relatively simple, it was a huge advance. And then in 2015, the Ethereum network launched, and Vitalik realized that you could do much more interesting things if you would allow people to install Turing-complete software on the blockchain and have that maintain state, right? And that's Ethereum. And there were a lot of evolutionary links between Bitcoin and Ethereum. They both used proof of work, although Bitcoin used longest chain, and Ethereum moved to this thing called greedy, heaviest observed subtree, which is slightly different. Looks more like a kind of tree. Anyway, Dfinity aims to produce something that's much more computer-like, right? And if you have a tamper-proof computer that isn't controlled by any central party, you can use the software for the purposes of smart contracts, right? Really, smart contracts are just software that run on a tamper-proof platform. But we believe the potential is much, much bigger than just a ledger or smart contracts. We believe that you can use a blockchain computer to pretty much host the world's IT infrastructure. And that's what Dfinity is about. So, we've sort of gone from token ledger to smart contracts to internet supercomputer. Whoops. So, what is the purpose? The purpose of the internet supercomputer is to enable us to upload to cyberspace software, data, computation, and money, right? These are critical things that make the modern world go around, that could be more usefully run on a tamper-proof internet computer that's completely reliable and can do things like protect privacy. So, these are pretty broad things, right? Software, that's private software systems, that's shared platforms, that's internet services, that's finance. Data, of course, is the state associated with the software, and the processing of the data, and of course, kind of money. So, thinking about where we're going and what Dfinity is supposed to do, you can sort of broadly divide up its purpose into these sort of 4 quadrants. So we start off with private software systems, right? So private software systems are things like e-commerce, HR system, inventory, audit trail, accounting, marketing, order management. So that's stuff that traditionally some businesses will build on Amazon Web Services, say, right? And we think it can be better run on the internet computer because we simplify the R&D model, we provide much better security guarantees, it's obviously much more reliable, it's unstoppable, and also has mechanisms to help people preserve the privacy of their data if they want. The next quadrant is decentralized business infrastructure. So there are a lot of industries that want to create shared systems, right? And it's very difficult to do it with traditional technology. So an example would be supply chain and trade finance. You can take some industry, and say the diamond industry, something like that, and you can usefully create a supply chain that tracks the movement of diamonds, right, all the way from the mines in Botswana to the guys that cut them in India, through to the jewelry shop in Paris, through to the Tiffany's in London, right? You can enable people to release liquidity tied up in invoices, which only get paid 3 months after they're submitted. You can do all kinds of cool things, but how would you persuade hundreds of participants in the diamond industry to choose one company to run the system that was going to connect them all, right? None of them would agree to it because they'd recognize that this one company that was going to run the system that would connect them all would accrue enormous power. And that's the first problem. They'd think, well, hang on, why am I agreeing to this? Why are we agreeing to give this company so much power? Secondly, of course, traditional technology is pretty insecure and pretty unreliable. So, you'd be putting a lot of trust in one system, right? That it wouldn't go down. And if it did go down, this whole industry would sort of grind to a halt. However, internet computer technology can solve that problem. First of all, you can create an open platform using autonomous software. So you don't have to have a company running the platform per se. There are ways of making that more open, right? And secondly, the system's unstoppable. So it's much easier to produce something that involves, large numbers of participants that's secure, and basically hack-proof, right? And there's a number of fields that, in a number of industries where this kind of thing might be done. I mean, in the US, there are all these different independent medical companies, right? And you can imagine they might use some shared platform to maintain those records, right? Such that any of them can access it. Ticketing is an example of how you might give an industry new revenues. So in the ticketing industry generally loses a lot of revenues to ticket touts. But you can imagine if all of the big venues like, soccer clubs, theaters, what have you, issue tickets, concert promoters issue tickets onto a shared platform such that if a customer didn't want to go to an event, they could just sell their ticket on this platform, get some credits, which they could later spend on another ticket. That would be good for their customers, but it would also be good for them because they could get a commission, right, back from the transfer of this ticket. So there are a number of industries that can, potentially create sort of open shared platforms that will increase their revenues enormously. So actually, there's a company called 55 Foundry, you might have heard about it yet, that is backed by the largest private equity company in the world, TPG, like 82 billion under management. And these guys have also got a fund which can call on up to $2 billion in investment into these kind of things. And they're planning on building a whole series of these shared industry platforms. So there's kind of a lot of momentum. It's surprising. The third quadrant is decentralized internet services. So some of these are kind of obvious, right? Craigslist. I mean, unless you're from Silicon Valley, you may not be aware of Craigslist. Is anyone here aware of Craigslist? Are you? Okay, cool. Yeah, it's just like a sort of, I don't know what you call it, like a online classifieds thing. There's a whole kind of spectrum of things that could be reinvented as what I call open source businesses, where you create the service using autonomous software that has a governance system built in, right? So you tokenize the service, and the governance system is run by the token holders. And the governance system, issues bounties and allows developers to effectively tender to implement requirements and things like that. And there's a broad range of reasons why these things can be successful. Now, I'll give you one simple example, which is Tinder. So Tinder's very popular in the United States. It's becoming very popular here. And there's, hundreds of millions of people who've used this thing, right? And they're on it for sometimes years and having lots of embarrassing chats. And what nobody considers is that probably those embarrassing chats are going to be public sometime, right? This is like Ashley Madison times 100,000, right? And it's just waiting to happen. So Tinder is just a small company, albeit a very valuable one, in Palo Alto, right? A few miles from the Dfinity Palo Alto Research Center. And if they make one configuration error in their network, the hackers are going to be in and take that Tinder chat database. If they have one disgruntled employee who goes crazy, the hackers are going to be in and take that Tinder chat database, right? If you really wanted to hack them, you could probably go and buy some of that, hacking gear from the Israeli companies, and then walk up and down outside their office, right, until you've collected enough electromagnetic waves from their keyboards to sort of work out how to get in, right? Tinder is not, people don't realize, right, there's like years of these embarrassing chats, right? Hundreds of millions of people. People are on Tinder, and they do it for a few years, and then they find someone they love and they get married, or in a stable relationship, right? Can you imagine, right? If when this thing comes out and it's on the internet, maybe the hackers just make it freely available. They just put it up there for the lulz, or maybe they say that you can get rid of your chats for a Bitcoin or something like that. I don't know. But it'd be like, damn, I'd love to see, what she said before she met me, kind of thing. And you find out she said the same thing, she said to the other guy, and then she goes on it and thinks, oh my God, you're a dirty bastard. And it's like, this is like a meltdown waiting to happen, right? People forget, with modern internet services, you don't own your data, and it's not secure either. So anyways, what you could do with Dfinity is reinvent Tinder as an autonomous open source, as an open source business using autonomous software. And there's new privacy tech which can enable you to run parts of the system in a mode where the data is encrypted, right? But it's processed inside of an enclave. And I won't try and explain what it is, but essentially it's a hardware mechanism that's being built into modern CPUs, right? So you could design the autonomous software that ran the decentralized Tinder in such a way that the chat database was a crypto lockbox, right? It's a crypto lockbox, so nobody ever, right, can get to those chats. And yet, you can still run software on those chats, which will go through the chats and tag users so it can match people together better, right? So the data remains available for processing by software algorithms, but it's impossible for a human to get hold of that chat data, other than obviously the participants in chats when they're looking through their thing, right? So this, I think, will be very appealing, especially when we see more, breaches like the Office of Personnel Management and Equifax and all these other kind of crazy disasters where everyone loses their personal data, right? So that's an example of a very powerful reason why I think people will eventually prefer decentralized internet services, right? Because they get guarantees about their data. And in this case, the guarantee could be that, all of the chat data is kept in a crypto lockbox, which because of the way the technology works, can still be analyzed by algorithms to tag users, but is inaccessible to any human being, even the people running the machines that are storing the data, right? But there are actually other reasons this will take off. I don't know how long it'll take, but it is going to happen. And one of the other reasons is what I call platform risk. So in Silicon Valley, VCs are very sensitive to this, and it means that if you build your system in a way that relies on someone else's platform, your future success is subject to their whims. So a good example would be Zynga. Who can remember what happened to Zynga? The games, they created this thing called Farmville, right? They were hugely successful, IPO'd, and worth $5 billion or something. And then Facebook suddenly decided that it wanted to change the way that games could promote themselves, right? And all of a sudden, Zynga couldn't promote its games anymore, and its value collapsed. And there's this is just one of hundreds of examples of platform risk in the internet services space. So what I think we'll see with decentralized internet services is that they'll be able to give people guarantees about the APIs that entrepreneurs are building on. So those entrepreneurs can't have the rug pulled from under their feet. So you'll see a kind of mutualized network effect that over time will make it much more attractive to innovators. Lastly, of course, we have decentralized finance. There's like ICOs, borrowing and lending. Borrowing and lending is a particularly interesting one. There's a project called Phi, which is also in the Dfinity stable, which aims to replace commercial banks with an algorithmic system. Prediction markets, as per Martin's stuff, insurance, token exchanges, escrow, money transfer. So, just in quick summary of the internet computer platform features, you have this ability to create autonomous software that runs independently of a person or organization, which can have an inbuilt governance system, or not, if you don't ever want to update it. We have a completely new software development model, right? which we believe can massively reduce the cost of R&D. We can provide privacy guarantees. We can provide for eternal execution. That means that you can write some software and have it run forever. There's no life cycle, right? It's not that your software starts up or the internet, someone flicks the power switch on the internet computer and you have to reinitialize it. It just runs forever. Hack-proof, and something called the actor model, which is a framework for interoperation. So, next question is, how is this network controlled? And this is where we're significantly different to, for example, Ethereum, where the code is law. On Dfinity, you have an algorithmic governance system. It's called the blockchain nervous system. It's actually pretty simple. It involves people creating neurons by staking Dfinities. This is just governance. It's nothing to do with consensus or anything like that. And the voting power of a neuron is proportional to the number of Dfinities staked inside of it. You get rewarded for voting. You can configure your neuron to follow other neurons. So for example, you can have your neuron on cryptography topics follow 5 other neurons. If 3 vote yes, you vote yes, adopt. If 3 vote reject, you follow reject. And if there's neither outcome by timeout, you just reject. But you can't get the Dfinities that you staked in the neuron back without dissolving it, which takes a year. It was going to be 3 months, but we've moved it to a year. But this blockchain nervous system, which effectively just, at least in the initial guise, just processes proposals, either adopts them or rejects them, is used to manipulate just about every single aspect of the network. Network economics, network structure, basic governance. Is it an ISIS slave market? Should it be frozen? Patch broken user systems, like the platform's hack-proof, but what if somebody's made a mistake when they designed their system, right? And then they may need some help, rebooting it and getting things working again. So it's what I'd call a fully adaptive network. And I think there's going to be some entertaining times when this thing's up and running. People, I think, are going to love to watch it and talk about the various proposals that are working their way through. So lastly, who's pursuing Dfinity? So Dfinity has a kind of slightly different philosophy. So, when Satoshi created Bitcoin, it was a very different world. Bitcoin is a very, 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 very basic protocol, right? Obviously, it's almost 10 years, well, it is 10 years old at this point. 10 years since the white paper, 9.5 years since the launch of the network. And it was possible for Satoshi and his pals to create the initial Bitcoin client, and pretty much that just continued running. But when you're talking about creating an internet computer that can support the world's IT infrastructure, right? All these different kinds of software systems, you need another level of reliability. It's not just enough to release some protocol into the world and hope it's okay. And to some extent, Ethereum's been caught short by this too, right? They created the Ethereum network, and then development kind of stopped, right? Actually, people demand continuous improvement, and certainly rapid fixes for security vulnerabilities that are found and so on. So the Dfinity strategy is to build out what we call a NASA for decentralization. So we're continually hiring, some of the very, best engineers and researchers in the world. So, we have guys like Andreas Rosberg, who is the co-creator of WebAssembly and runs that standards process. He was a senior Google staff engineer. We have a guy called Ben Lin, who's the L from BLS cryptography that everyone's wanting to use now. We have Timo Hanke, who created ASIC Boost. Jan Kamenisch has just joined. He's was a principal research scientist at IBM and created, was an early pioneer of lattice cryptography. So we are expanding the organization as fast as we can. We've got bases all around the world, or people all around the world, at least. And our objective is to scale this to hundreds of people. And so it's kind of like the opposite of strategies that you see at other blockchains. And the reason is we believe that anyone who tells you that you can create an internet computer that's going to be trustworthy enough and reliable enough to take over the world with just a few guys in a garage selling you snake oil, it just won't work. This is really, really complex technology, and it touches on everything from, distributed computing to cryptography to virtual machines to language design to developer stack to low-level hardware architectures when you're looking at like enclaves to provide privacy features. And if you really want to make all of these things work together and produce a platform that's sufficiently reliable and trustworthy that you can really scale this out on a super massive scale, you need a massive team of brilliant people behind it, and that's what we've been building at Dfinity. If people are interested, please check out dfinity.org/jobs. There's always a variety of jobs. It's not just technical jobs. Yeah. And that's kind of it from this brief intro. This is actually from a few weeks ago. This video here is of the this is Manoush Movhedi. She's kind of reasonably well known in distributed computing scene. And this is the test network a few weeks ago. And yeah, you can, if you could see here, you'd see this is the block time. The block time currently is just over a second. We can get finality in 2 blocks in normal operations. So, for us, we want finality in 1 to 3 seconds. That compares to about 600 seconds for Ethereum today and 3,600 seconds for Bitcoin. And this isn't using some sort of Ponzi, traditional BFT scheme that's totally unsuitable for the decentralized network setting. This is using a fully decentralized network. And in fact, you can probably see from this network, there are huge, our network's designed to run with tens of millions of computers, none of which have some special role like the 21 servers in EOS, right? All of them, it's a symmetric network. Every computer is equal. So it is by some margin the most decentralized distributed blockchain ever created. So it's exciting times anyway, but we're hoping to get this out, end of this year, beginning of next year. And that, I think, will really kind of spell the beginning of some interesting times in the blockchain space. Anyway, that's it. I thought I'd just run through this and go straight to Q&A. I don't know how much time we've got.
So first question. Hi, you talked about Dfinity allowing open source solutions where companies wouldn't collect data, for example, the distributed Tinder.
Yeah.
What about the Dfinity network incentivizes companies not to collect data? Because obviously Tinder could not collect data if they didn't want to, but they do for whatever reasons. So why do people on the Dfinity network not want to collect data?
I think, so the reason that something like Tinder collects data is so that whatever device you log in from, you can see your chats, right? So like if you're using WhatsApp, I've got WhatsApp on my phone, I've got WhatsApp on my laptop, and if I'm using my phone and then I put my phone away and I open my laptop, I can see the latest chat messages, right? So that's the reason that people like having central databases. The point is, this introduces a vulnerability. Currently, if you have an internet service that collects everyone's data, in some central server room, it's very vulnerable, right? If the network's misconfigured, or you have a disgruntled employee, it's pretty straightforward for a hacker to suck that data out, and with catastrophic consequences. It can be anything from causing relationship difficulties on a grand scale with Tinder, through to having your life ruined by identity theft with something like the Office of Personnel Management, which also actually lost like 20 million people's most intimate secrets that through this sort of high security vetting process had been revealed through this high security vetting process. So a decentralized Tinder would use the crypto lockbox, the fact that the chat database would be kept in a secure crypto lockbox that couldn't be broken, as a selling point. So they would say, hey, everybody, you want to use internet dating, but aren't you a bit worried about Ashley Madison happening to Tinder? Well, here's the solution: use decentralized Tinder. And it's just as good at matching you to people, because inside that crypto, the algorithms can run inside of that crypto lockbox to tag people and analyze the content of the messages. But no human being can extract those messages from the crypto lockbox, right? So that could be a major selling point. And also, of course, you can design that in such a way using autonomous software that you know exactly what's done with your data, right? You don't have to trust some company who says, yeah, we're not going to do this, we're not going to do that, right? But it's all subject to the whims of management, and they need to turn a profit. So I think, generally, I think there's a sort of growing awareness of this problem with the central hosting of data on private servers. And we've seen it with messaging, right? People are demanding encrypted messaging. WhatsApp adopted the Signal system. And, there's a sort of growing outcry about Facebook and the way it can listen to what you're saying to target ads at you and all this kind of stuff. And so I think, over time, more and more people will sort of look towards this kind of system.
Just as a follow-up to that question, I wondered, it sounds like the question was a little bit more about the incentive for a company to build on it when their pricing model is about collecting data. If that's how they make money as a profit, then would they be necessarily giving up access to metadata about their users? Or inside this crypto box enclave, when you said that it can still match appropriate users, that's metadata about those users. What level of interaction does a company have with metadata about that?
Well, so the first thing is it's not a company, right? That's the whole point. So we believe that internet services will be reinvented as open source businesses. So the open source software development model will be reapplied to businesses. So there won't be a company or an organization backing these systems. It'll be autonomous software with an inbuilt governance system. So the service will be tokenized in some way. Those tokens will give you influence within the governance system, and the governance system will adopt update software updates and bug fixes and so on. But it's sort of reminiscent of the open sourcing of business, right? There isn't an organization. It's just a piece of autonomous software. A bit like, you can imagine the DAO, for example. The DAO was, is a very simple example of an open source venture fund, right? And, decentralized Tinder will be something similar. And, I haven't thought about it, but, there will always be ways to create some kind of return that can get directed to the holders of the tokens. And I would say that, if you ICO decentralized Tinder and it was a great system, the tokens would probably become pretty valuable. So that would be the incentive for somebody to create it. And then obviously as it went forward, it would pay bounties to developers to, who are able to submit updates and bug fixes.
Thank you for the presentation. Talking about the blockchain nervous system, can you talk a bit about how do you deal with non-participation risk from a game theoretic point of view, without economic centralization, though?
Yeah. So it's actually fun enough. I started thinking about there's an algorithm called Wait for Quiet that I actually proposed for the DAO. So back in, was it 2016 or 2015? 2016, right? Yeah, so in the sort of spring of 2016, I was desperately proposing design alternatives for the DAO because I felt that it was fundamentally insecure, but I was looking at it from the sort of perspective of the overall design. I wasn't imagining that they had a reentrancy bug, right? So for example, you have problems like ambush voting, right? You could put a really bad proposal into the DAO to fund something that was really truly awful, and a smattering of people would vote against it. So it would look like that it was going to fail, and so nobody would bother to vote. And then just before the cutoff time for voting, whoever supported the terribly bad proposal would sort of come in with all their votes, and push it into a winning position without denying anybody a chance to respond. So that reflects the fact that you cannot really use traditional governance systems in the decentralized in a decentralized setting. So it's not a boardroom. It's having 12 people on a board, 12 men and women on a board that know each other and sit in the same room and have reputation and can get fired and all this kind of stuff is completely different to say 20,000 anonymous DAO voters, right? So blockchain nervous system. So one of the problems is, which you've alluded to, is that what happens if nobody votes, right? So you don't want to. You have to have very low, thresholds. Yeah. Otherwise, the danger is there's just not enough voters. And then the problem becomes, how do you avoid all that kind of stuff? Right? How do you avoid ambush voting and stuff? So this uses a system that I originally proposed for the DAO, or at least at the moment, called Wait for Quiet. And it works as follows. It has a concept of noise, right? And every vote that comes in is like hitting a cymbal. It makes a noise and the noise decays, right? So, as the votes are coming in, there's lots of noise, right? Lots of hits on the cymbal. But once the noise has passed a threshold, or you've got a certain number of votes in, not noise, you then wait for the noise to fall beneath the threshold and then decide. So, you don't wait for absolute quiet, because otherwise, somebody could keep on submitting like one vote, right? Wait for that to die away, then another vote, and just drag it out forever. So you set a minimum noise threshold when you decide that, ensures basically that everything's quieting down, and you've settled on it. You should have settled on a decision, but you're not waiting for absolute quiet, because that would be another attack vector. Does that make sense?
Kinda. So it's
You're just basically it's like thinking about the human brain, right? When you're thinking about a problem, you're evaluating different alternatives, and eventually you start to settle on one, and you'd see the noise from the neurons settling down as you basically decided, yeah, this is the right option. It's the inspiration. It's where the inspiration comes from.
Okay. Thank you. Thank you.
So in the past, Dfinity's blockchain nervous system has been promoted as the AI is law, as opposed to the code is law. But from what's been released so far, it only seems like stake-based votings. Are there any machine learning techniques that you are planning on to apply, or is that the noise system you just described?
Yeah, so it's certainly not like a traditional AI that you train on a massive data set or something like that. It's a different kind of thing. I don't know what, it's like an algorithmic wisdom of crowd system, right? But it does take inspiration from the brain, if you like, and it can learn, if, for example, if, let's imagine there's a Make Dfinity Great Again guy that appears on Reddit, right? And he tells people to follow him because he's going to make Dfinity great again. And he publishes his neuron address on his Reddit post and his big loud mouth. And over time he persuades people to reconfigure their neurons to follow him on economics or something like that, right? And so everyone reconfigures their neurons to follow this Make Dfinity Great Again dude on economic, on proposals. I have the economics topic. And then eventually, the Make Dfinity Great Again dude submits a economics proposal that gets adopted because most people can't be bothered to vote. Their neurons are just following, right? And it goes, it goes wrong, right? So in this situation, the markets will punish the value of Dfinities, right? The people will see in the broader world, look, the blockchain nervous system is adopting this crazy economics proposal submitted by the Make Dfinity Great Again guy, right? And the markets will punish the value of Dfinities, and ultimately the objective of the blockchain nervous system is to increase the value of Dfinities. And the dopamine, if you like, is the market price, right? And people would look at this and go, holy cow, what was I doing following this dude, right? I just lost a load of money because, the voting power of your neuron is proportional to the Dfinities you've got staked inside of it. And hopefully go in and reconfigure their neuron to follow someone other than the Make Dfinity Great Again dude. So, in that sense, the blockchain nervous system can learn and, and it sort of cascades to decisions and all kinds of other things. So it's kind of new, I don't know, it's like an algorithmic governance system really, right? But what's interesting is you can create, you can use traditional AIs to create neurons. So potentially, if you've got a traditional AI that, somehow analyzes trends and, I don't know, previous proposals and has some way of kind of applying some Bayesian mathematics or something to guess whether a proposal is good or bad, you can imagine that, people might say, right, I'm going to configure my neuron to follow 5 people, right? 5 other neurons. 4 of them are going to be people, and 1 of them is going to be this AI. So that's how traditional AI systems would be integrated into the system as individual neurons that people could configure their neurons to follow.
Okay, sounds good.
So maybe one question from the back now.
Great. So I actually have 2 questions. The first one is also on Ethereum and many other blockchains that are storing data. The idea that data is later deleted or pruned, maybe something like GDPR, or you're just migrating your schema. Do you have an idea for that in Dfinity? And the second question is, what is something that you're very excited for that will be built on Dfinity?
So, with respect to data, Dfinity, you probably guessed, doesn't work like a traditional blockchain that stores every single transaction. Just wouldn't work. So if you had 1,000 shards and each shard could process 1,000 transactions a second, that's like 1,000,000 transactions a second. We instead focus on cryptography that ensures that the state can only be updated in legal ways, right? It can only be updated by genuine transactions, and that transactions can't be replayed and things like that. So, we provide very strong security guarantees that the state, the data associated with all that software running on the internet computer is only updated by the correct execution of the software. It can't be tampered with, but we don't store all of the transactions. And if you want to, create an audit trail and log something, then you just, have your software, create its own event log, right? So the other question about GDPR is, there's this thing that you have to keep the data in the country or something like that. The internet computer isn't designed to satisfy regulators. It's designed to solve problems. And I'm sure those regulators couldn't even imagine in their wildest dreams what they'll see in a year or so, right? So I would say with respect to GDPR, it may very well may turn out that the law doesn't apply to the internet computer. So although we're calling it the internet computer, remember it doesn't really exist. It's not like there's some computer sitting in a room. It doesn't have a geography. It's an entirely virtual thing conjured up by the protocol itself. And, you can interact with this thing by sending messages, right? Or using a client library or whatever it is, and it, it looks like a computer, smells like a computer. You can install software on it, and you can run the software, and it'll maintain data and so on, as though it's been installed on a server. But it's not installed on a server. The internet computer doesn't really exist as a computer. It's a virtual thing that's created by all of the protocol interactions. So, whether it can be, whether you can really say that you're storing data on a computer, I don't know. You're really storing data inside of a protocol, right? You're storing data inside of a protocol state. So I don't think GDPR applies to the internet computer. Having said that, it is possible to run a private shard. So we had a couple of different ways to handle shard design. One way is we've got this thing called validation towers and validation trees, and you can prevent a shard from ever corrupting itself. You can always catch it when it would deviate from a correct state, like by processing a fraudulent transaction or something. But this increases the latency, cross-shard communication latency. So we actually prefer a system where the shards are made pretty robust, and they have a configurable width, as you can choose the number of replicas, but they're also protected by enclave attestation and various other things. But if a shard, we accept that a shard could fail, right? And if a shard fails, it can be corrupted, and all the definitives on that shard can be stolen. And people can choose what kind of shard they want to go onto when considering the trade-offs. But what it does, there are various benefits. One is, we can greatly reduce the latency of cross-shard communication, and software that's installed on two different shards wants to communicate. But also, we can allow governments and businesses to run their own shards if they want to, because the overall system contains the damage to a single shard. So if some company runs its own shard, well, let's say, okay, it's great, it's protected. Let's say they're running 16 symmetric replicas. It's 16 replicas in the shard. Well, it's pretty good, it's pretty reliable, 16 replicas. It's a pretty good software system, but if they get hacked, it's a central single security domain, and they could lose all their data because some hacker could get in and wipe all the replicas or something, right? But that's their risk. The point is, if that happens, the contagion stops there. They can lose the definitives on the shard. Their shard can get corrupted, but they can't corrupt other shards. You don't have a weakest link problem. So I guess the answer is I don't think GDPR will apply to the internet computer, because the internet computer isn't really a computer, right? It's just really something that looks and smells like a computer that's created by these protocol interactions, right? It's a computer that doesn't exist. It doesn't even have a geography. But if somebody really wants to take internet computer literally, or for whatever other reason believes that running all your own nodes is more secure than just using the ones that Dfinity randomly assigns to you, they can run their own shard.
All right, so one last question.
We can do more. I'm happy to answer a few until they're all gone.
Hi, could you maybe elaborate on validation towers, validation trees, and how the security is handled there? Because there is a problem that usually you lose some security by sharding the system, and
that's right. So, we're not going to use validation towers and validation trees. At least at the moment, we're not, right? So that was a theory that I developed in 2015, which solves the problem. So, what's apparent if you look at like Bitcoin or Ethereum, if every single sort of full node, or is performing the same computation, right, which is a complete waste. And it's a great shame that amount of repetition and replication of effort is necessary to create security. So the question is, can you get the same security from, sort of say, 90 nodes performing the computation as you can from 10,000? And as it turns out, you can get almost the same security. And it works by using random numbers to put people in a game where you build this tower, you have to commit to validating some state transitions, executions of transactions, and also some levels beneath you in the validation tower. And that you have to be buried yourself some number of levels deep in order to continue as an economic entity within the network. And you can basically show that the adversary's financial resources will be quickly exhausted if he tries to get fake transactions through. And so it's just not it's not practical. He would need trillions and trillions of dollars before he ever succeeded. And of course, no one has that much money, so it's impossible. But actually, the trouble with validation towers is that the validation and the finalization, if you like, of state involves at least 3 levels of validation, right? Probably 4. And each of those is driven by the random beacon, which is like every second or something. So, I actually think in practice it'll add more like 6-7 seconds of latency to cross-shard communication. And we don't want that because, we want a system that provides a good user experience without using state channels or any kind of other layer 2 tricks. And if you've got finality in 1 or 2 seconds, that's a pretty good user experience. On Reddit, if you press submit on your post, 1, 2, done, right? It's fine. So we don't want to slow down the responsiveness for cross-shard communication too much. And so we decided in the end it was better to have a system where shards could fail. But when they did fail, they weren't going to be weakest links. So for example, all the definities into a shard are counted in, and all the definities out of a shard are counted out, right? Such that even if somebody takes over a shard, they can steal all the definitives on that shard, but they can't manufacture new definitives. And of course, it's the token, it's the network token that mediates participation. If you lose control of that, the network's dead. So that can't happen. The shard can have different widths, so it's 8, 16, 32, 64, 128. Obviously 100.
That's the number of nodes in the shard?
Yeah, number of symmetric replicas. So, these are selected randomly from the overall population. So you'd be very unlucky if you had 128 replica shard if the adversary managed to get 65 of them, right, and blew it up. Very, very difficult thing for the adversary to do. But actually, we can also use hardware attestation to create another level of difficulty. So even if you have a shard, the thinnest shard, which would be 8 replicas, and the adversary gets 5, which is still very difficult actually if you look at the kind of way we've architected the network. Because most miners won't just have one replica that you can bribe them to hand over if you can find out who they are, of course, in the first place, which is difficult. They're miners with lots and lots of replicas, and they don't want to devalue the network by giving you some replica so you can hack a shard, right? So, but yeah, even if that happened, you also to actually corrupt the shard, you also need to get past the hardware attestation, and that will be very, very difficult to do. And if that happens, let's say we're using, the shards have different kinds of hardware as well. So you have like, Intel SGX shard, AMD secure virtual machine shard, maybe a RISC-V shard with a new open source enclave and so on. And, let's say that, it turns out that Intel put a backdoor into its SGX system, right? And then Edward Snowden sort of steals this and puts it on WikiLeaks, and now all of a sudden anyone can fake the attestations. In that calamitous situation, where the attacker's got 5 out of the 8 replicas and the hardware attestation has been broken by some crazy backdoor being made public, even in that situation, the collapse of that shard cannot break the other shards. But obviously that shard, the software on that shard becomes unreliable along with the data.
Okay, thanks.
So, unfortunately, we have to cut it off here because of the neighbors. It's past 10. We are in Germany, so we have to be quiet now. But I'm pretty sure Dom, Martin, and Cory will be very happy to take additional questions. So now it's time to mingle, take some dessert, drink some wine, and yeah. That's it for today. Thank you, everyone, for showing up.